Hey. Okay, I think that's working. Yeah, it helps if I hit the button. Hello, hello. Do, 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 do. Let's see. How is everyone doing today? Do, 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 do. Do, 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 do. Alright, well, if shit's broken, just let me know. Just scream at me. As loud as you can. I will hear you through the ether of the cosmos. Da, 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 do, 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 do. All right, so I think today I could mess around with the thingy a little bit more, but I think what I want to do when this thing starts working, I think what I want to do is mess around with this other thing that I've been playing with. And trying to. You guys have been watching my other streams. I've been toying around with SPI and I2C and other low-level communications, like over-the-wire communications. And I was just trying to make some demo stuff to mess around with that. So we'll see. We'll see how that works. Cool. Okie dokie. I guess that'll work until it doesn't. Hello. Okay. I've got this in here. I think I do. Or not. Okay, here we go. All right, just getting a couple things open, like usual. Let's see. All right, so let me clear a couple things off my bench. Okie dokie. That is what this thing was for. I guess I should turn on some music. When I start singing, it's because there's no music. Okay. I don't know what to listen to. It'd be so much easier if I could just listen to copyrighted music. Oh, let's see if this works. Boo, 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 boo. Okay, so let me get some stuff plugged in. Essentially, the way this is going to work is one of these. I think it's this one. Yeah, this one is my logic analyzer. And then this guy is basically running this code over here. So, just to kind of go through what the code does really quick. It's pretty straightforward. It's just running MicroPython on this board, and the MicroPython is essentially what it's doing is it's setting up the hardware SPI bus, setting the baud rate to 20 megahertz, using all the default settings for like polarity and phase and all that other good stuff. And I've got this configured for pins 6, 7, 4, and 5 for the chip select. And then I've got some code right here that goes and operates the NeoPixel LED that's on the board. Or at least this sets it up. This sets it up, figures it basically. It gives us our LED object. And then I've got a function, or not function, but a little bit of code that does that connects to the SPI bus, and it sends this over the SPI. See, with SPI.write message. And then it flashes our LED, sleeps for 1/10 of a second. And then it flashes the LED again back to red, so RGB. So it just flashes it green for a brief moment, and then goes to sleep, and then sets it back to red. And that's just to give me like a visual indication that the thing is actually doing stuff. So let me get my other power cable. Where is my other power cable? You would think that I just have Type-C cables lying around everywhere, right? Okay, I just need something simple to get power to this board. I guess we could do data with it. I'll probably have to update the code anyway. Oh, when it inevitably doesn't work. Okay. Okay. And you should see that it sort of blinks. Maybe it's too bright. No. Oh. There you go. But it's doing stuff. Promise. I promise. So, what it's doing is it's just spitting out 4 A's over and over and over. Every little bit. And then I've got this. So I've got this one running, and then this is the main code that runs. So it just runs our SPI demo, sleeps for 3 seconds, and then runs it again. And every time it runs the SPI demo, it goes and it does this. So if I need to set this in the, let's do, hello, keyboard. Okay, SPI. Oh, okay, hold on. So we need SPI, and then, yes, it's gonna be our chip select. There, now now we're not configuring it every time we run, we're just configuring it once when the thing turns on. And then I think we can also do this. No, we'll leave that one. Move the LED. SPI and chip select. Select connection. Let's see, we want this one, WTTY ECM1. Sync to device. Okay, and then, oh, SPI is in the bind. Adoy! There we go. Okie dokie. Chip select isn't defined. We need chip select isn't. Oh, it's in here, isn't it? Yes. Yes. My careless changing of code. That's what I get. All right, so it's spinning that out. Okay, cool. Now what I want to do is we are going to run pulse view, and I'm going to connect these up. Right, it was pins 4, 5, 6, and 7, right? Six, 7, 4, and 5. So 4, 5, 6, and 7. Okay, cool. And then go ahead and pick our device, serial port. Oh, no, hold on. Open bench, OLS, serial port, scan for devices, grab that. And turn off all of these except for 0, 4, 5, 6, and 7. This one's going to be our ground. Put this right there. And then put our sample rate up to 100 megahertz. Rename a couple of these. So 4 your meso, 5 is chip select. And then 6 is what, Mosey? Oh, 6 is clock, and 7 is Mosey. All right, and then let's go ahead and run it. Of course, it's not going to do anything. I mean, it'll do something, but we're not faster than the computer, so what we need to do is set up a trigger. And what I want to do is mess with the trigger on this clock line. So when this one goes high, we run and see what that does. Nothing? Okay. Do we do it again? Ah, okay, there we go. I've got some stuff over here. And then we'll bring up our protocol, decoders, run SPI one. Oh. And this is the part that I was kind of having trouble with, and kind of why I wanted to mess around with this device in the first place. Really set up a demo. It's because this does not look anything. So this is what we're going to be looking at, right? Is master out, slave in. And this data doesn't look anything like what I'm sending. And I need to figure out how to get it to look like that data. It should be a bunch of A's, right? We should see 4 A's. Nothing? What if we do Mosey trigger? Nothing, huh? Okay. Doo-doo-doo. Is it the number of samples, or is it the... Crank this up to 200. That shouldn't make a difference, should it? Well, now it's not getting anything. What's up with that? It's still running. And part of me wonders if, like, MicroPython is doing something with the SPI, or maybe it's like a frame setup or something instead of just raw dogging the data. MicroPython. Oops. Alright, so our SPI bus. Let's see. We might try it with the software SPI too and see what that is. Oh, maybe it's too fast. Is this that's 100 hertz, right? No. What about if I come in here and crank this down to like 100,000? No, wait. 200,000 samples. Uh-huh. OZ transfer, huh? But what did it transfer? About when our chip select line goes low. Try that one. But it just seems to trigger when it's high anyway. No? Yeah, I feel like there's something that I'm missing with like the baud rate or something. In the case of hardware SPI, the actual clock frequency may be lower than the requested baud rate. This is dependent on platform hardware. The actual rate may be determined by printing the SPI object. Interesting. You're telling me that if, print SPI. Oh, okay. So, if I change it to, what did I have it? Oh, interesting. So when I was trying to do 20 megahertz, I think that's 20 megahertz, it was limited to 12 megahertz, right? Yes. Huh. What about if I do just like 100 kilohertz? And then come over here, and I say that my... And the recommendation is, I think, what, like 5 or so times faster sampling rate? Let's do that. Not do it on the chip select, let's do it on the clock signal. I think that was a bit more reliable. Still nothing though. Is this thing even getting anything now? Okay. I'll just be faster than the computer, right? Part of me wonders if my wires are bad or something. I don't know. Who knows? Definitely not me. Do-do-do. So pull CS low. And right set to our SPI bus, changes our LED, and when it's done it pulls CS high again. Oh, you know, maybe I should do... Maybe I should be putting our CS back to high as soon as we're done. And let's see what that does. Uh-huh. I don't see that going high. What are you tripping about? Huh. Let's see. So baud rate is the bit rate measured in bits a second, kbits or megabits a second. I'm not sure that clarifies anything. fast data sent over serial line expressed in units bits per second. Usually won't see speeds exceeding 11,5200. I guess that's kind of like, when I printed out this, it would only go to, what was it, 12? How does that translate to, like, my sample size and sample rate? Each block used by the data is transmitted in a packet or frame of bits. Frames are created by appending synchronization and parity bits to our data. Maybe this is what I'm saying. But does SPI do that? Because this is all just serial. Like generic serial. Okay. Write the bytes contained in buffer returns none. Set the first bit to be LSB or MSB. Let me do that just so that I know for sure which one it's doing. Oh, that's just. Oh, okay. I gotta do it over here, first bit. Okay, first bit is most significant bit. What is that? Is this just moderate? Hold on. Frequency of 400,000 kilohertz. Okay. That answers that question. So it's at 100,000 kilohertz. Which makes me think that this should be picking it up. Why? Why is it triggering when it's high? It should be triggering when it goes low. Oh, I can also do this. We trigger capture ratio 20%. If that gives us anything interesting. Oh, that was interesting. It crashed. Because it didn't like that. That was too interesting. Alright. What was this one, Mosey? No, this one, sorry, that was Mizo. Mizo. Make it our CS. This is going to be our clock. And this is our Mosey. Right? And 7 is Mosey, clock is 6. 4 is Mizo, and 5 is chip select. Okay. Leo. And then try this again. Okay, now let's set our trigger on the chip select when it goes low. See what that gives us. Nothing. It's the same thing. I don't understand why it's like that. Nah, it crashes again. That's interesting. I wonder why that happens. Oh, you know what? I think I've got these backwards, no? No. I don't. I thought I did. Okay. Is it because I didn't have the ground plugged in? Or did I just unplug that accidentally? Alright, here we go again. I wonder if I can save this. None, 0, 4, 5, 6, 7. I'm gonna get fast at this. Alright, can I save session setup? View SPI setup. Okay, there. Now I can just open it when it crashes again. Speaking of, let's go ahead and set the pre-trigger. If it crashes one more time. Okay, that didn't crash. If I set that to low trigger again, and it crashes. What the hecky? Alright. Do I need to update that? I mean, I just did. This is pulse view 0.4.2. Is it query? No. Search? This? Lust. Sudo apt lust. 4.2. Okay, so that's the one that's installed. I'm guessing it's just the nano analyzer. Oh. Okay. Interesting. That was a weird result, didn't zoom in. Okay, whatever. Set our clock trigger too high. It crashes again. No? Okay. Is it just the pre-trigger capture ratio? Let's set it to 10%. Huh. Hey, no D-Ref, what's up? How's it going? I don't think he likes the 20%. Let's see. Yeah, it doesn't like it when I set that to 20%. That's whack. What is this supposed to be saved as? Click Team Fusion. I have no idea what that is. That sounds fun though. I was digging around in a might mess with this later, but I was digging around in a Android application for my robot vacuum. Oh, that's cool. Common tool set. Yeah, I was messing around with the Android app for my robot vacuum, and they had like a little bit of code that was supposed to be like doing some AES decryption off a blob that was stored in the assets. And I was like, oh, that's really interesting. So I just wrote some Python real quick to reverse engineer that, or to decrypt the AES, and it was just some JSON. Yeah. It was pretty straightforward. I think it was worse than CBC. I don't know all the mechanisms for AES, but it was not very difficult. They had the initialization vector and the key stored in the same blob. It was all base 64 encoded. The first 32 bytes for the key, and then the next like 16 bytes for the IV, I believe. Any tips for a computer science grad who wants to start tinkering with electronics but has no prior experience? Yeah, just dive in. Find something that's interesting to you, whether it be, low-level electronics, like building circuits, or whether it's the software that controls the circuits, or what. I'd say just dive in. Is there a particular thing that interests you the most about this stuff? CTR, yeah, that's it. Alright, so this thing hates it when I do a pre-trigger capture ratio of 20%, so... So I still don't know what this pattern is. I guess it's external or internal triggers? I don't know, hold on. Oh, nice. Yeah, most of that stuff goes over my head because I don't sit down and spend a lot of time remembering it. So I have to relearn it every single time. Other features. Isn't it? No. Triggers? I don't know what that setting does. You would think that they would talk about that in their docs, but nope. Device-specific settings, so maybe that's something to do with the You didn't just deny when they asked you to write ECV and Zig. You didn't just say no. I've never actually messed with the command line. Hey, what's up? How are you doing, Fappy QQ? ARD being Apple Remote Desktop. I guess this was for personal use, which is less egregious. Yeah, so I don't think this thing is going to tell me why or what that's all about. Pattern. I'm guessing it's external or internal triggers. There we go, set pattern. Is this it? I don't know if this explains how that pattern works. Maybe it's not under here. Maybe it is under main. Oops. No. I want to search in this repo. Handlers, that does not seem useful. Way more fun than doing div helmet exchanges by hand. That is some high quality nerd shit right there. Doing div helmet exchanges for fun. I don't know what all this code is doing. It's well commented though. Maybe I do need to set this to like internal or something. And then maybe that'll work when I set that now. No. You didn't bust out your abacus? Your TI-83 graphing calculator? Oh, that looks juice. Okay, now let's try this again. Ooh, I think that's it. 41, 41, 41. That's all A in ASCII, isn't it? Here, let's see. Copy annotation to clipboard, and then we go to Cyber Chef. I love you, Cyber Chef. Wow! Yay! Ah! Yeah, this is a scream of joy. Yay! Oh yeah, that's a good point. TI-83 doing 1024-bit numbers. That sounds like a crazy video project. I implemented AES 1024-bit encryption on my TI-83 graphing calculator. Alright, cool. So now what I want to do is, what I kind of wanted to turn this into is sort of like a little CTF, like hardware CTF. But it's mostly just like a demo so that I could test my own ability to pick this stuff up properly. I don't know why. Actually, here. So it's at 100 kilohertz, and we're capturing. Wait, was it at? Yes, 100 kilohertz. And our sample rate is 200 kilohertz, and we're doing 100,000 samples a second. Well, per instance, I guess. That's another thing that I don't understand, is why it doesn't actually trigger when it goes low. Is this thing like looking for an external signal or something? Is that what that is? Oops. Post-quantum crypto. Yeah, Matt Parker would do that. I think he's mathematically masochistic enough. And he'd do it all on a whiteboard, too. That would be the fucked up part. What is the external for? I don't understand what that is. External and internal. Do it for the clickbait. The only reference to external or internal that I have is for that crystal oscillator. Huh. I don't know. I don't know what this setting is for. Leave it to none, I guess. Okay, so if it's not going to consistently trigger on the chip select line, let's try. When I was messing with it earlier, it was working on the clock line. We'll see. Or not. Maybe I need to... See, that's the thing that I wanted to make this for, is to kind of like play around with, have a consistent result coming from the hardware, so that I can play around with the pulse view software and my logic analyzer and figure out what the best way to capture data is, or like process. And make demos for myself. Why does that not pick it up? Because normally the clock line should be going high. I'm so confused. Is this the part where I need to up the sample rate? Because it's... No. No! And I don't know if it groups these conditions or not for the triggers. But I feel like that would be something useful too. Is that why it hasn't triggered yet? It's because it's waiting for all of these. Let's do that. We'll do clock and cable select. No? Or cable select, chip select. I'm ratting on myself and showing my age. If I haven't done that already, right? So that grabbed it that time. But it's not right. Why is it not right? This doesn't look like If I put it back down to 100 kilohertz and run it again, is this no, that's not right either. I guess it was just blind luck that I grabbed it that first time. And I caught it at 200 kilohertz, right? Let's see. Because they mentioned like the sample rate, device configuration. The sample rate you choose must be at least twice that of the highest frequency you want to capture, ideally 3 to 5 times as much so that you have some margin. That way jittering signal won't ruin your measurements. So if we're at 100 kilohertz, then we'll do 500 kilohertz. Nothing. Curse you. Curse you, hardware and demo gods. Okay, well, I need to go get some more coffee and go to the bathroom. So I'll let this thing think about it, what it's done, and I'll come back. So, be right back 1 second. I have returned. Right, let's see. Do. All right. All right, you think this thing's playing nice now? Probably not. I wonder why I got the correct result that one time and not again, not ever again. Hmm? Nope. Yeah, that's not right. So all this nonsense over here, all this is all because I did more samples than necessary, I'm guessing. So, oh. Is it reliably grabbing it now? Yeah, but the data's not right. Hmm. And now it's just not going to grab it at all when I put it 20k samples? I wonder if this, hardware is just not great for this software. This RPi 2040. I have some, I think I have another Raspberry Pi 2040 that I can use. Herm. No, pulse feed doesn't really have. It says the trigger system is awaiting extension. Grouping's only done for convenience. There's no functional impact. Okay. Special purpose. Oh yeah, the guess bit rate's kind of neat. If it worked. Yeah, that's so strange to me. I don't understand why it comes out differently. I bring it down to like 200 kilohertz. Wait a minute. Okay, so that is kilohertz. It's already kilohertz. I get back and it starts working a little bit, and now it's not doing anything. Oh. 05, 05, 05. That's still not right. Why? I wonder if it's my wires. Because, I don't know. It just seems odd that you'd see the chip select line go up and then down again so quickly. And it worked once. Huh. I can move it closer? I don't know if closer would work. I could try directly to this thingy instead of the of going through the breadboard. Alright, hold on. What's really in there? Alright. Bruh. There we go. Alright, so if I go directly to... Get rid of that. I'm fishing for more cables. Wait. No, I need... Damn it! Oh, of course, I don't have one more. Oh, but I do. It's just in the pile somewhere. There we go. All right. Yeah, I think that's good. And then, I have 4 wires right there sitting in front of me. Jeez. And then our power connector. I don't think this is gonna do anything, but we'll eliminate 1/2 of the breadboard connection in case it's awful. Any day now. Nothing? Why is it so inconsistent? Alright, time for this one to come off the breadboard. Been a minute since this one has come off the breadboard. Alright. Make sure I got them all lined up right. You're going to pin 7. That's a solid connection. Okay. And this guy. Our ground connection goes over here to pin 0. Like so. Alright, we'll plug it back in. My mess of wires now. Oops. Change it to OLS. Alright. Set the trigger. Okay. Oh. Alright, it doesn't have our decoder, but that's okay. Let's put it back on there. All of our stuff is named properly, so I should just do it 050505. That's not right. What is wrong with you? Okay, so we'll do 500 kilohertz. Let's see what result we get with that. When we get a result. I don't know why these triggers are so inconsistent. That's not right either. Bruh. What happens if we put it at exactly 100 kilohertz? So with the sample rate faster, 500 kilohertz, we're still not getting the data accurately. Oh, shit. I wonder if I can put a delay after my chip select. Oops. And then I can do another one right before I put my chip select high again. Yeah, I think the sample rate definitely has to be high enough in order to grab that. I'm sure 1 megahertz. Oops. Nothing. Oh, here, let me do that. What was that? There's nothing. What are you triggering on? Huh. Alright, I'm about to bust out the scope. This is really confusing. Verify. Do I have to... Let's see. Do I need to connect ground? I do, right? It's a stupid question, but one that I've never considered. Do I just connect ground to ground? What if I do that? Instead of doing... Because there's a ground pin on here. Just do ground to ground. Maybe it's not picking it up properly because it's not grounded appropriately. Truly, I have no idea. Watch this just work though, right? Nope. That does look a lot clearer though. Maybe. Okay, I think that delay is a little too long. And now it's just triggering for no reason whatsoever. Oops. Surely there's something wrong. Still not sure if that does anything or what that actually changes. Swapping the pattern around. Oops. Yeah, I don't get it. Works sometimes, doesn't work other times. Very, very confusing. Like, this won't even grab it when the chip select goes low. Okie dokie. Oops. Yeah, that's our chip select line. Huh. Alright. Massive cables. Let's see. I guess we're going back onto the breadboard, huh? I mean, unplugging it or separating it off the breadboard definitely didn't help anything. There we go. Get this all wired back up. All right. And then, is it the ground pin? I have the ground for that one. Ground goes right there, and then I'll grab another one. Do. There we go. This one. And wire it up to our scope as our ground. And then I need one more. I guess I could use 4 so that I can actually measure all of it. I guess I don't need 4, I just need 3 of them. Viso is 4, 5, 6, and 6. Yeah, so we just need 5, 6, and 7. We're not sending anything from the peripherals. Okay. Now, let's check out the chip select signal first, which is in 5. Maybe this yellow one, right? Let's do auto really quick. That's a horrible idea. I don't know why I do that. Okay, so this thing is... Is this our chip select? That is, right? Why is it so noisy? Oh, it's not even plugged in. Dead doy! There we go, 1 volt. Let's do 1 volt. So it is triggering, and we can see it. It is doing stuff. So that is a thing. I guess we get some more probes out. Okie dokie. Alright. Man, YouTube hates my music. Every, like, song, it's like, hey, we're gonna turn off your stream because you're listening to music. We don't like that. Even though I have permission to listen to this music. Alright, get probe number 2. What are you doing? What did I do? Oh, I set it to 100 volts. Alright, there we go. And I think you guys can see that. I don't know if you can see that at the top left. I put the scope in the scope. Okie dokie. And then let's see, so channel 2. What do I got for channel 2? So channel 2 is, that is our orange one, right? Yes. Which is that our clock pin in 6. Seven is going to be our Mosey. Yeah, so I think that's our clock pin. Let me zoom in on that a little bit. And then let's get our third channel on. Just going to be our Mosey pin, master out, slave in. I need to start calling it Pokey and Pico. I like Pokey and Pico. Makes more sense anyway. I think I can decode with this scope. Where are we at? Our math. Decode 1. Decoder RS-232. SPI. Let's see. Clock is going to be channel 2. Mizo is off. Pico is our peripheral in, controller out. Going to be channel, is that 3? Yes. Decode on. Oops. What is decoding stuff? Let's see. Most significant bit, format ASC. I'm guessing that's ASCII, right? Yeah. Clock is channel 2. Mizo is off. Mosey's channel 3. Exchange. Clock and data. Huh. I don't know what that's all about, but... Alright, so... Can I get a single of this? And then can I zoom in? See what those are? Position? What is that? Oh. I can move its position. That's fun. Label on, format off. Huh, that's fun. Okay. I've not actually explored these options in here. EVT table, event table? That's interesting. Width 12. Do I need to set that to 8? Timeout mode. What is that? Oh, cable select. Cable select. Chip select. Oh my goodness. Mode chip select. Chip select is going to be number 1. Okay, so interesting. It's not actually decoding it into anything. It says it should be hex. Interesting, interesting. Oh! Hey, look at that. Okay. I changed the decoding to ASCII, or the format to ASCII. I don't know if you guys can see this, but I think I need to set up that tool. I had some. Let me see if I can do that. Anyway. Yeah, like you probably see that, right? Look at those A's. So the scope decodes it. But this stupid thing, this stupid logic analyzer doesn't. That's kind of annoying. So now I'm kind of curious. If I go back in here and I change these, I don't know. Why does it not pick it up on the on this guy? Oops. See, it just doesn't pick it up when the chip select goes low. I don't understand. Alright, maximum sample rate. Let's do this. We'll do it when our clock signal goes high. Come on. I just want to see the 4 A's on pulse view again. Give them to me. Give me the 4 A's. Is that it? No, that doesn't look like it. 0A, 0A. What the? Bruh. What is wrong with this software? Am I stupid? What am I doing wrong? It works on the scope. Oh, you guys can't even see this. Man. Look at that shit. Isn't that stupid? That's not right. It's not 305s. It's supposed to be 41s, right? 341s? Yeah, or 441s. Wait, what the fuck is going on? I wonder if I can connect a different logic analyzer. Alright, hold on. Do I have it over here? Maybe this one's just unreliable and shitty. And maybe it's not Pulse View, maybe it's just the Raspberry Pi 2040 that I'm using. Can I use the Tigard for logic analyzing or no? Logic analyzer port 2. Observe device level signals. The LA port. It's the 127 to 2 by 7 pin header. Using an external logic analyzer. Oh. Gotcha. So, where is that port? Oh, this one right here. This is the LA port. Okie dokie. Alright, 1 second. This one might do the trick. So this is the Bitmagic Basic. This guy. Right here. And let's see, we're gonna unplug this. I don't want to take those out, so I don't want to do this. I guess I'm getting more wires out. Okie dokie. And one more of these? No. More wires. south. Okay. Alright, these are labeled, but I don't know what the fuck they're labeled for. Got T1, T2, IF, CL, ground, 2, 0. Let's see if we can find... S doesn't matter, right? Alright, 0, 1, and 2. That's what we've got. Alright, so I've got 0, 1, and 2. And let's go ahead and plug that up. We may need our ground. Probably need our ground. Most definitely need our ground. Alright, it's gonna be confusing, but... Alright, we have our ground plugged up. And I don't know... This thing works. It's been a minute. Acquisition of CPU trace data in combination with orbiculum. What the fuck is that? Orbiculum? Oh, demux and post-processing software. Interesting. Okay. Alright, and I think we need this one, FX2. Could be completely wrong. I'm probably completely wrong. Let's see, sudo dmessage h. Sorry, ACM3? Wait. Oh, okay. I don't think it's actually picking it up. Detected out of the box by Sigrock. Okay. Oh, maybe it's just USB and not serial port. Oh, there it is. Okie dokie. Oh, okay. Nice, that's cool. Love that for me. Wowie! Are you serious? What the hell? What about if I don't have any wires plugged into it? And then, no, it still airs. Oh, this is killing me. None of my tools are working. Why? And YouTube wants to ban my music again. Okay. Question. Why does this not work? Why do you not work? No protection circuitry, no input protection. So that's for this one. What if I could decode it with the flipper 0? Bruh, YouTube. Is there any music that you do like me to play? Alright, crazy. YouTube streaming is awful when it comes to music. Why is it like that? Why are you like that, YouTube? Why can't you just be normal? Hello, keyboard. Oh, okay. Oh, you can connect to full speed. That's crazy. Okay. Alright, where's my flipper? One moment. Oh, Flipper! Oh, Flipper, where are you? Hello, Flipper. Alright, I wonder if I've already got this on here. Somehow I doubt it. SPI terminal. Let's see if this shows up. That'll be fun. Clearly this didn't work. I'll have to mess with this thing later and figure out what its deal is. Alright, so it's saying Mosey on 2, these are 3. Alright, so this should be which one is my Mosey? And 7 was Mosey, right? Alright, 5 is clock, 4 is CS. Let's see. I need and then my ground goes into ground. Oh, look at that. Wow, isn't that cool? Gotta get you a good view of it. Look at that. That's cool. It's playing all of the A's. So now, if I come in here and what I wanted to do was make it so that this, let's see. I don't want to just shove a bunch of data in here, a bunch of random crap. Let's see. MicroPython libraries. Is it port specific? No, not port specific. Python standard libraries. Where's my random? Get random bits, right? An integer within random bits. All right, should that should give me, what is it, a 2-byte value? Unsupported types for add tuple and bytes. I think I need to convert this into something else. Oh, yeah. Okay, well, let's just join these then. We'll do dot join. Oops. Probably still not gonna like it, but whatever. Join expects a list of string bytes objects consistent with self object. What the fuck? Oh. Huh. Oops. Oh. Is that what it wants? Is it 2 bytes? No, wait. I cannot remember. What the fuck is this error? I've never seen this error before. Running byte list Python. Is it not iterating through the tuple of the date? What is going on here? It thinks it's 2021. I just now realized that. What the fuck? Oh no, wait, it's time since the epoch, right? No, wait. Local time. Am I? No, I'm not getting local time. What am I getting? I am getting local time. What? Yeah, you just do that. What? Bruh. And then it bitches and complains that list of string/byte objects consistent with self object. Wow, what a diva. What are you whining about? I'm just gonna... Okay, let's see. Let's check this really quick. Print type E, print type T0. Couple integer. Is it trying to... Let me just do list comprehension, I guess. We'll just do this. We'll do T join T. It'll be... for I N E. No? Inu? Six hours later. Okay. Unsupported type, add bytes, integer, bit. Oh. Byte tights. Two bytes. Buffer too small. What buffer? Well, that one pulls it up. Okay, so let's do this 2 bytes. That's probably going to whine that the buffer's too small. String object has no attribute 2 bytes. Well, you know what? Well, what is it? Is it decode? String object has no attribute 2 bytes. It's encode. Oh my god. Jesus. Holy crap. I can never remember that. No, I guess that works. Okay. Yeah. I don't know if it's picking it up on here, though. Let's see. Oh, here we go. Let's do a single. Now, can we zoom in? I wonder what keeps it from actually decoding it when it's this much. Oops. Why isn't it actually getting it this time? Huh. I don't know why it's not picking it up on the scope this time, but that's interesting. Okay. Why does it not work with this, though? I'm so confused why this thing doesn't work. I had it to work once. What? That's not what I'm sending. And now it's not going to pick it up again, huh? Ooh. Yeah, that's not it either. That's definitely not it. So this is, I guess that's kind of a sign that your sample rate is too slow, maybe? No? It's missing like the front half of this. Last time I did this, it crashed. Let's see. No? Interesting. So I wonder if that's too fast. I wonder if you can have too fast of a sample rate. Is that a thing? Okay, hold on. Super secret flag. see, 2 hex, so we're looking for 7B and 7D for the parentheses. Nope. And that crashed again. Hmm. 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 Okay. Yeah, that's not pulling up the data either. Huh. Interesting. Interesting. Okie dokie. Hmm. That's interesting. Okay. Well, I don't know why it's like that. I wonder if it's just because it's more data. Yeah, I really don't know. Because when I was just sending like 4As, it was able to pick it up pretty well. Threshold set? No. CH2 is our clock. Meso's off, Mosey is CH3. Everything seems right. I didn't change anything between then and doing it now. Change it back to Let's see. Like that. And immediately we can see that it changes on the scope. And obviously that's working. So, I don't know. I'm not sure what the big difference is between... Whoa. Oh, demo device. Music has stopped again. Alright, well, approaching 3 hours of streaming, I think. I've messed around enough in the lab today. I have to go to the bathroom, and I'm getting a little hungry, so I think I'll call it quits here. Thanks for hanging out, those of you that did. And I might be on later, but no guarantees. So, all right. Well, thank you so much for hanging out. And if you guys enjoyed this, you know the drill. Check the description. I've got a Discord, I've got a YouTube channel, all that other good stuff. And I will see you guys later.